Okay, I think this is working. Out of the hang of it. There we go. So just going through the revision solutions for the functions PDF. I'm just going to be working through these really quickly. Okay, so for example 10, fully simplify root 72, take root 50 plus root 12, where root 72 is the same as 36 times 2. 50 is 25 times 2, 12, 6 times 2, that's not going to help, 4 times 3. Don't forget, we're looking for the square numbers. Well, 1's not going to be very useful, but 4, 9, 16, 25, 14, 36, 49, etc. Okay, so 36 and 2, that becomes 6 root 2 because we square root the 36, but we can't square root the 2. Take 5 root 2 plus 2 root 3 because the square root of 4 is 2. Now these two can go together, but the 2 root 3 can't. So we've got 1 root 2 or just root 2 plus 2 root 3. With the next one, example 11, we've got root 15 take root 6 squared. Now you could expand the brackets, like literally write it down, root 15 take root 6, root 15 take root 6. But we're going to take the shortcut. Remember, every time something squared, it's the first one squared, root 15 squared. Because there's a minus, we're going to have minus 2 times the first one, root 15, times the second one, root 6, plus the second one squared, root 6 squared. Now, root 15 squared is 15. Root 6 squared is 6. This one becomes 2 times square root of 15 times 6. I really wish I had a calculator with me. I do not. 90. Hopefully, yes. Okay. And that means we've got 15 plus 6 becomes 21. Take 2 root. Now, what square number is going to 90? 9 is the only one I can think of. 9 times 10. So this 9 itself is going to end up as 3 when it comes out the front, but there's a 2 out the front, so we multiply them. So it's going to be 3 times 2 is 6 root 10. We'll leave it as that. Hopefully. Yes, got it right. Okay, example 12. Now, every time they ask you to simplify a fraction with surds on the bottom, they want you to rationalize. And the quick tip for rationalizing is multiply it by the conjugate over the conjugate. Conjugate means you change the sign on the bottom. So we've got 1 on 2 root 3, take 3 root 2. We're going to times that by 2 root 3 plus 3 root 2, 2 root 3 plus 3 root 2. So on the top, we're obviously going to get 2 root 3 plus 3 root 2. On the bottom, the reason we chose to do this is because if I've got A take B times A plus B, that becomes A squared take B squared. It's difference of 2 squares. So on the bottom, 2 root 3 squared is going to be 4 times root 3 squared. I'll just write this step out. You probably would skip that. And then minus, and now we've got 3 root 2 times 3 root 2. We've got 9 times root 2 squared. So we're going to have 2 root 3 plus 3 root 2 on the top. On the bottom, root 3 squared is 3, so 4 times 3 is 12. Root 2 squared is 2, so 9 times 2 is 18. So we're going to end up with 2 root 3 plus 3 root 2 over negative 6. I'm just going to chuck the negative out the front. Question 13 is essentially the same thing, but they want us to pretty up our answer. We're going to end up rationalizing the denominator, but then we're going to express it as one thing plus another thing times root 5. So if we've got 2 over root 5 plus 1, well, to rationalize, we're going to have root 5 take 1, root 5 take 1. So I should continue my working out over here. 2 times root 5 is 2 root 5. 2 times 1 is 2. Root 5 squared is 5. 1 squared is 1. So we've got 2 root 5 take 2 on 4. If I split these up, then we've got 2 root 5 on 4. Take 2 on 4. I'm going to rearrange this. I'm going to have the 2 on just the number first, because in this one, I want whatever doesn't have a surd with it first, and then I want whatever does have a surd expressed separately. So we've got -1/2 plus half times √5, if you can see. So the number with the surd is +1/2. The number without a surd is -1/2. So we've got A equals -1/2, B equals +1/2. Okay. Next one, every time you want to find the equation of a straight line, we'll do A first. First thing, well, we're going to aim to use the gradient intercept formula. I mean, not gradient intercept. This one, you know what I mean. Y take y1 equals m outside of x take x1. And don't forget m is the gradient. That's y2 take y1 over x2 take x1. So we need to know m first. So for us, m is going to be, doesn't matter which order we do these. I'm going to do x1, y1, x2, y2. So for me, I'm going to have 4 take -2 over -3 take 1. So I've got 6 over -4, which gives me -3 on 2. That's my gradient. So the actual equation itself, y minus y1 for me was -2. It doesn't matter if I chose to do y2 and x2 for this one, by the way, equals -3 on 2 outside of x minus x1 was 1. So y plus 2 is -3 on 2x plus 3 on 2. I want to get rid of that 2. I subtract it. So I've got -3 on 2x, take 1/2. Now for B, the important bit with this question is the word perpendicular. That means we're going to have to use the fact that m2 times m1 equals -1. So essentially what that is the gradient of our perpendicular line is -1 over the gradient of the other line. So we've got the gradient of our new line is going to be -1 over -3 on 2. So it's going to be +2/3. And again, we're going to use our y take y1 equals m outside of x take x1. We know it goes through A, which means we're going to have to use these points as our x1, y1. So we've got y take -2 equals, this time it's +2/3 outside of x take 1. So y plus 2 equals 2/3 x take 2/3. So we've got y equals 2/3 x take, oh my gosh, 2 and 2/3. What's that going to be? -8 on 3. I don't have my calculator. Apologies if that's wrong. Okay. With questions like this is a piecewise function. It's defined differently for different sections. So when x is less than 0, it's going to be looking like x squared. When it's between 0 and 4, it's going to look like 3x. And other than that, it's going to look like 12. So let me just get some nice grid of paper up. The first thing we should be doing is double checking that these are all going to meet, or where it's going to be at the end of everything. So what I mean by that is I should check when x is 0, x squared is 0. When x is 0, 3x is 0. The other end of this one is going to be x is 4, 3x is going to be 12. And then when x is 4, this is just going to be 12. So it's going to look something like, I just know I want it to go through. Okay, just pretend I can draw. It's going to look like a parabola, but then it's going to start going up like 3x, and then it's just going to keep going across at 12. So 4, 0, this is 12. Y and x. Okay, if I'm sketching the absolute value of 2x take 1, one way to sketch things like this is to just ignore the absolute value signs, give it a sketch, and then make it bounce back. So all your, wherever y would have come out as negative is no longer negative. So let's have a look. 2x take 1. It's going up. It has a y-intercept of -1. Its x-intercept is going to be a half. Let me change this a bit. I don't want to smush it up that much. -1, half. Now, normally, this graph would look like this, but we're doing the absolute value. So instead of looking like that, what it's going to do is, yeah, sure, from here up, it's going to look like that, but it's going to turn all those negative values into positive values. And down here, it was just y equals 2x, take 1. Okay, if we're solving equations, though, it's actually a much simpler process. If I've got 2x take 1 equals 3, I could do it off my graph if I did my graph well enough, which I usually don't. I'm going to do it algebraically. Okay, so I've got positive 2x take 1 equals 3 and negative 2x take 1 equals 3, which means 2x equals 4, x equals 2 is one of my solutions. Negative 2x plus 1 equals 3, negative 2x equals 2, x equals -1 is another one of my solutions. So let's just have a look. X equals 2, 1, 2 is here. X equals -1, yeah, that's down here. That's about right. Looking good. All right, finding the roots of quadratics is wherever this comes out as 0. Let me just have a look. I don't know how much time I've got left and it won't tell me. Okay, hopefully I'm on track and this won't just end. I want to get this done in one video. So essentially we're solving whenever this equals 0. So x squared plus 5x plus 6 equals 0. You could use a quadratic formula, but that's kind of overkill. Factorizing is your friend here. We want to PSF it. So product is 6. The sum is 5. So the two things that multiply to give 6, add to give 5. 3, 2. Don't forget, when you're solving these, you're trying to solve when this whole thing comes out as 0. This will come out as 0 when x is -3, because -3 plus 3 is 0. And x is -2. Okay. If we do example 33a, we're trying to now sketch this graph. We've got y equals x squared takes 6x plus 8. First thing we want to find is the y-intercept. Let x equal 0. X equals 0. You can clearly see y is 8. Next thing we want, x-intercepts. Y equals 0. This is the same as finding the roots. So we've got 0 equals x squared takes 6x plus 8. Again, you could quadratic formula it, whatever. I'm just going to factorize two things that multiply to give +8, add to give -4. -6 is -4 and -2. So x equals 4, x equals 2. There are two x-intercepts. The next thing we want is the vertex. Now, this is when the derivative equals 0. You could complete the square, put it into turning point form, and find the vertex that way. You could use x equals -b/2a, which is just remembering that it's just a formula that actually just gives you the derivative. Y dash equals 0. That's going to come out as 0. So we're going to have, well, y dash is 2x takes 6. So when that comes out as 0, so x equals take 6 over, then divide by 2, we've got 3, which is the same as -b/2a, because minus -6 became +6 over 2 times 1. yeah, gives us the same answer. And then sub that in to find the y coordinate, because we just know how far along it's going to turn. I don't know how far up or down. So we've got also, that's halfway between the x-intercepts. That would have been a bit of a quicker way to find this. So we've got y equals 3 squared take 6 times 3 plus 8. 9 take 18, negative 9 plus 8, y equals negative 1. I hope I'm right. I really wish I had my calculator. That's enough. We could examine the concavity and stuff, but putting these points on our graph will be enough to tell us the important stuff that's going to happen. So we draw our little graph, y, x, chuck the important bits on. Let's make that 8, 2, 4. And we know it's turning around at negative 1. So we know it's going to kind of go through that, and back up. Put our little arrows on. Okay, 33b, we had y equals, this one's a harder one, I like it, because it's not going to be so easy to factorize. Using the quadratic formula might be the quickest way to find the roots. Y equals negative 2x squared plus 9x take 7. Same process. Y-intercept x equals 0. So we've got y, it's just going to be negative 7. X-intercepts, y equals 0. And I do want you to write this out before you then go through and use the quadratic formula. So 0 equals negative 2x squared plus 9x take 7. So a is negative 2, b is 9, c is negative 7. So x is going to be minus b, so minus 2 plus minus the square root of b squared. So minus 2, no. Oh gosh, I'm an idiot. 9 squared take 4 times a, negative 2 times c, negative 7. Glad I didn't persevere with that. Over 2 times a, negative 2. So we've got x equals minus 9 plus minus the square root of 81. 8 times 7, 56, take 56. All over negative 4, 81 take 56. Really wish I had a calculator. I might just go over to Officeworks. 25. Oh, this is nice. We've got minus 9 plus minus the square root of 25 over minus 4. So we've got minus 9 plus minus 5 over minus 4. So minus 9 take 5 is negative 14 over minus 4, and x equals minus 9 plus 5, positive 4, negative 4 over negative 4. So x is going to be 7 on 2 and 1. Okay, next step is the vertex. It's when the derivative is 0. Let me just remind myself. Okay, so our derivative is going to be, take the 2 down the front, we've got negative 4x plus 9, and that's going to be 0. So we've got negative 4x equals negative 9, so we've got 9 on 4. Sub that in to then find y. Oh, I really wish I had a calculator. Y is going to be negative 2 times 9 on 4 squared plus 9 times 9 on 4 take 7. Negative 2 times 81 on 16 plus 81 on 4 takes 7. Something. No, I should actually figure this out. That's really annoying. No, I'm not figuring that out. Whatever. And then we sketch. Now, normally I would use the y coordinate of the turning point to really help me out with figuring out what it's going to look like. But this time, because I wrote something I don't actually know, But my x-intercepts are going to be 1 and 7 on 2, that's like 3.5. My x-coordinate of is going to be halfway between those, so that was 9 on 4. My y-intercept is -7, so y-coord. I'm just going to pretend it came out as that. And it's going to look like that, but better. Okay, find the equation of this. Okay, we could try and put it into turning point form, but we don't actually have the turning point, so this isn't going to be very useful. But we do know the intercepts. So we know it's going to be y equals something outside of x plus 2, x take 4, because we know the zeros are -2 and 4, and we know once it had been factorized, it would look like that. We're going to use the intercept to find out. So we know when x is 0, y is -24. So we've got -24 equals a outside of 0 plus 2, 0 take 4. So -24 equals -8a. So a is 3. So our formula is 3 outside of x plus 2, x take 4. I mean, we could expand it. If this was a multiple choice question, they'd probably ask us, they'd probably give it an expanded form and we'd be trying to figure out which one was which. Sketch these parabolas. Okay, I'm assuming that these won't come out nicely. I apologize. I'm going to skip these. You can always use Desmos to check your answers. I kind of wish I had a calculator. Okay. This one, we know the turning point is 3, 2. So because we know the turning point, I'm going to try and put it into y equals a x take h squared plus k. So we know the turning point is the x coordinate is 3. It's been moved 3 to the right and it's been moved 2 up. I don't know why I put that in bracket there, but I don't know a yet. I'm going to use the fact that they've given us the intercept when x is 0, y is -16. So we've got -16 equals a outside of x, 0, take 3 squared plus 2. So -16 equals 9a plus 2. Take 2 over, divide by 9. A must be -2, which means we've got y equals -2, x take 3 squared plus 2. Okay, when they're asking questions like this, they're using facts about the discriminant. As you probably remember, the discriminant is b squared take 4ac. It's a bit under the square root in the quadratic formula. If this comes out as a negative, you can't square root it. There's no answers, no roots. If it comes out as exactly 0, there's exactly one answer because you're going to be plus minusing 0. And if it comes out as a positive number, then you're plus minusing something. So there's 2 answers. So for equal roots, that's when the discriminant equals 0. No real roots, that's when the discriminant is less than 0. So let's do 41a. So for here, my discriminant is b squared. So it's negative lambda take 5 squared take 4 times a, which is 1, times c, which is 9. I'm just using square brackets because I wanted something different when I squared that negative lambda take 5. Anyway, don't stress about it. So we've got, this is going to come out as, this negative is going to disappear. So we're going to just have lambda take 5 squared, take 36. Now for it to have equal roots, that's when it's 0. So that means 0 is lambda take 5 squared take 36. So 36 is lambda take 5 squared, square root it, we've got plus minus 6 equals lambda take 5. So lambda equals 5 plus or minus 6. So those 2 answers. 5 plus 6 is 11. 5 take 6, -1. Okay, now for it to have no real roots, that's when lambda take 5 squared take 36 is less than 0. Now, we know it's going to happen around the 11 and the 1. We don't know whether it's between them or outside of them. So the easiest way to do this is to do a really quick rudimentary sketch. We're going to treat lambda like it's just an x. So this is just a normal quadratic concave up, like smiley face. And it's me moved right 5 down negative 36. So I don't actually care what it's going to look like. When, for it to be less than 0, that means it's within the -1 and the 11. So that comes out as less than 0 when it's between -1 and 11. It doesn't include those values because those values are when it's exactly 0. Okay. This next one was a doozy. We did it on the revision day and it was satisfying to complete. Find as a relation between, oh no, we didn't do it on the revision day, we did it last day of term. Find as a relation between K, L, and M, the condition for this to have real roots. Simplify your answer as far as possible. Now, this is going to have real roots when the discriminant is bigger than 0. Real roots. So the discriminant is b squared take 4ac. So b is 2l outside of k plus m. So we've got b squared take 4 times a, which is k squared plus l squared, and c, which is l squared plus m squared. We want that when that's bigger than 0. So this is what we're focusing on solving. Okay, 2l outside of k plus m squared. I've got 4l squared k plus m squared. Take 4k squared plus l squared plus m squared. And I'm looking for this to come out as bigger than 0. We may as well expand, I guess. I always think I'm losing if I'm expanding. So we've got 4l squared times k squared plus 2km plus m squared. Take 4. Now we're going to have k squared l squared plus k squared m squared plus l to the 4 plus l squared m squared greater than 0. All right. 4l squared k squared plus 8l squared km plus 4l squared m squared. Take 4k squared l squared. Take 4k squared m squared. Take 4l to the 4. Take 4l squared m squared, bigger than 0. Let's start cancelling out these ones. So l squared k squared, l squared k squared, l squared m squared, l squared m squared. So we've got when negative 4l to the 4 plus 8l squared km take 4k squared m squared is bigger than 0. This is kind of like another quadratic in itself. We've got negative 4l squared squared plus 8km times l squared. Take 4k squared m squared. I'm going to divide everything by negative 4. It's going to make it a bit simpler. So I've got l squared squared. Take 2km times l squared plus k squared m squared. So we're trying to find out when this one is bigger than 0. So it's easiest to find out when it is 0 and then check values in between. This is another quadratic itself. If I've got L squared equals U, then this is U squared, take 2km times U plus k squared m squared. This is a take b all squared. Because I think we've got u squared or L squared squared. I might just get rid of the whole U thing. Oh, no. There we go. We've got L squared squared, take 2 times L squared times KM plus KM squared. So we're actually factorizing L squared take KM when that comes out as bigger than 0 squared. Well, that's when L squared take KM. Like the whole thing's always going to be bigger than 0, but it's when I think I've confused myself. Well, let's solve firstly when it is 0. I don't know what I've done to confuse myself. I don't know. I'm leaving it there. It came out nicely. This one's much easier. Functions and not functions, vertical line test, because each value of x has to map to, so has to correspond to a single value of y. You can't have 2 values of y for a certain value of x. You have to know, given that value of x, exactly what value of y it's going to come out as. So the easiest way to check that is the vertical line test. You can see that the first 2 pass. Yes. Yes. Second one is not. It's not a function. This one is also not a function because if we do a vertical line test exactly there, these are both colored in circles, it fails. Okay, next one, we're just subbing in different values. So when they talk about f of 1, that means we've got 1 squared plus 4 times 1 plus 1, which is going to be 6. If they talk about f of -3, then we've got -3 squared plus 4 times -3 plus 1. If you're just spamming these in your calculator, make sure you put brackets around that negative. So we've got 9, take 12, -3 plus 1, -2. C, find f of k. Now we're just replacing the x's with k's. So we've got k squared plus 4k plus 1. D, f of k plus 1. Well, we've got k plus 1 squared plus 4 times k plus 1 plus 1, which gives us k squared plus 2k plus 1 plus 4k plus 4 plus 1, k squared plus 6k plus 2. And for E, f of 3 take k, we've got, this is really annoying, 3 take k squared plus 4 times 3 take k plus 1. So we've got 9 take 6k plus k squared plus 12 take 4k plus 1. So we've got k squared take 10k, 9 plus 12, 21 plus 1 plus 22. And F, sketch the function. X squared 4x1. We know how to sketch function. We know how to sketch functions. So you're welcome to do that, but I'm not. Okay. Draw a function machine. Yeah, I don't know. And we're going to evaluate these. So f of g of x means we've got 7 times g of x squared. So 2x plus 5 squared plus 3. So wherever we have x, we're going to replace it with this whole thing, which gives us 7 times 2x plus 5 to the 4 plus 3. You can expand that or not. If I've got g of f of x, then we've got 2 times 7x squared plus 3 plus 5 squared. So this time we've got 14x squared plus 6 plus 5 squared gives us 14x squared plus 11 squared. And I'm not going to expand that. Oh, we're nearly there. State the exclusions from the domain. Here, x cannot equal 2. X is everything less than 5 on 2. We're not including 5 on 2. This dotted line means it's an asymptote. Here, x does not equal plus or minus 3, or we could write it as x is less than 3 and negative 3. Negative 3 is less than x is less than 3, and x is greater than 3. I prefer this one. Or we could write it as all real numbers excluding x equals plus minus 3. They're fancy ways of writing the same thing. Natural domain, square roots. We don't want it to come out as a negative. So x is less than or equal to 6. No, x is greater than or equal to 6. Thank you. Reciprocal functions, like a fraction, we don't want the bottom to be 0, so x does not equal negative 2. Here, x has got to be bigger than or equal to negative 1/3. Here, x cannot be 2, but it cannot also be negative 2, because negative 2 squared is obviously 4. Okay, this one. We want x squared to be less than 4. So we need x to be between negative 2, or less than or equal to, and positive 2. F x cannot be negative 2 and x cannot be 3. G, x has to be bigger than or equal to 6. And x has to be bigger than or equal to negative 3. We go with the most restrictive of these. Because if it's bigger than or equal to 6, then it's automatically going to be bigger than or equal to negative 3, like we've satisfied both. This one, we don't want the bottom to be 0, and we don't want it to be a negative, so x has to be bigger than 4, but it can't be bigger than or equal to 4. If it was equal to 4, then we would have a 0 on the bottom. This one, we just need x squared to come out as something less than 16, so it has to be between negative 4 and 4. Cannot equal those, because then the bottom will come out as 0. This one, x does not equal negative 9, and x does not equal positive 3 on 2. Yeah. This one, x squared take 9, it just can't come out as a negative, so x squared has to be bigger than 9. So x squared has to be bigger than 9. So x can be less than or equal to negative 3, and x can be bigger than or equal to positive 3. Another way to write this is the absolute value of x has to be bigger than 3. On the bottom, we know x squared has to come out as bigger than 1. It can't come out as equal to 1. So we've got a really similar thing. X has to be less than -1, or X has to be bigger than 1, but it can't be in between. So absolute value of X has to be bigger than 1. Sketching this one, this is just a lovely a cubic. It's been moved right 2 and up 3. So when it says all important features, we need intercepts. So y-intercept X equals 0, y equals 0 take 2 cubed is -8 plus 3, -5. X-intercept y equals 0. So we've got 0 equals X take 2 cubed plus 3. So we've got -3 is X take 2 cubed. So we've got the cubed root of -3 is X take 2. So X equals +2 plus the cubed root of -3. I just know that's a positive number. So it's going to look like that. It's one of the worst sketches I've ever done. Polynomials. Okay. If there's no power to the brackets, as we discussed, if there's no power to the brackets, it's going to look like a linear function when it's going through there. If it looks like if there's a squared on the brackets, it's going to look like a parabola. If it's a cubed on the brackets, it's going to look like a cubic. Let's do question A. One thing that I want you to do for all of these, they do give you the x-intercepts, but you have to find the y-intercept by letting x equals 0. So y, we're going to have +1 times -2 times -3. It's going to be 6. So when I do the graph for A, I know it's going to go through -1. I know it's going to go through +2 and +3. And I know it's going to go through y equals +6. So it must have to look like that. -1, 6, 2, and 3. For B, we've got y equals x outside of x take 2 squared. The y-intercept is going to be 0, obviously. Now, this one, a little more in depth because, yes, I know it's going to go through the x-intercept, the origin. Yes, I know it's going to go through 2, but I don't know if it's going to go through like that. Like that. Easiest way to find out is to chuck a value that's to the left or to the right of this kind of area. So if you're chucking like -10 or something, do it in your head, like the -10 take 2, that's going to be squared, so we're going to have positive, but we're going to multiply it by the -10 out the front. It's going to be down here. So yes, we've got a graph that looks like this. Okay. For C, we've got y equals x take 2 cubed, x plus 1. So y-intercept, we make x equals 0. We've got y equals -8 times +1, -8. When we come to sketch this one, I'm going through -8, I'm going through +2, and I'm going through -1. Must have to go that way. And now because that's cubic, it's going to look like that at the x take 2 cubed. And D, well, y-intercept, we make x equals 0. So y is going to come out as 0 as well. For this one, we've got a whole bunch of linear factors, but we won't know whether we're going to be coming up from the bottom left or top left, etc. So chuck a value to the left or to the right. If I chuck a negative number in, I'm going to have like a negative. Hang on, let me double check. So it's going to go through 0. It's going to go through +1, +2, and -1. If I chuck in, for example, -10, I'm going to have negative, negative 10, so a positive, times a negative, times a negative, times a negative, which means it's going to be a negative. So it must be going zoom, 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 zoom. The equation for the lowest degree, okay, so here's linear. So this one's going to be x take 4. Here looks like a parabola, so it's going to be x take 1 squared. Here looks like a cubic, so it's going to be x plus 4 cubed. And I don't know the number out the front. So we're going to have y equals a, x plus 4 cubed, x take 1 squared, x take 4. What we do know is that that's the y-intercept 512, so x equals 0, y equals 512, and I'm really going to regret not having a calculator. We've got 512 equals a times 0 plus 4 cubed, 64 times 1 times negative 4, 256, so we've got 512 equals negative 256a, so a equals negative 2. So we've got y equals negative 2, x plus 4 cubed, x take 1 squared, x take 4. Simple enough. Circles, hooray! The center. This one has been moved left nothing and down 5, so 0, negative 5. The radius 4. So don't forget, hopefully you remember, we've got x take h squared plus y take k squared equals r squared. So the center is at h comma k. So here the center is at 7 comma 8. The radius must be root 2. Okay, for these ones, we need to complete the square to do this. I have no idea how long this has been going, and I don't know when it's going to cut me off. It used to give you a timer. So we need to complete the square. So for question A, we've got our x squared take 10x plus y squared plus 8y plus 32 equals 0. So we're going to do it first with the x's, then we're going to do it with the y's, and then we're going to tidy everything up. So we've got x take 10 on 2, which is 5 squared. Then we have to subtract off that 5 squared, plus y plus 8 on 2 is 4 squared. We've got to subtract off that 4 squared. And then we've got that 32 still left over. So we've got x take 5 squared plus y plus 4 squared. And then we've got negative 25 take 16. I need a calculator. 25 take 16, negative 41 plus 32 take 9. So that equals 9. So the center is at 5 comma negative 4. The radius is at 3. For question B, we've got, I'm going to rearrange it, x squared plus 8x plus y squared take 14y equals 35. So we've got x plus 4 squared take 4 squared plus y take 7 squared take 7 squared equals 35. The 4 squared and 7 squared, we've got x. 16 and 49. So we're going to have take 65, but I'm going to want to add that on, move it over, add it on to the 35. It's going to come out as 100. So we've got the center as negative 4 comma 7, radius 10. Okay, question C. X is together, Y is together. So we've got X take 18 on 2 is 9. squared, we're going to have to subtract that off, plus y take 20 on 2 is 10 squared, take 10 squared, got that plus 60 on at the end, 0. So we've got x take 9 squared plus y take 10 squared, negative 81. Okay, we've got 81, we've got 100. So we've got take 121. So that's going to become equals 121. So the center is at 9, 10. The radius is 11. I reckon someone set out with those numbers. And D, fractions, my nemesis. Like, how dare they? Okay, we've got x squared. Again, I'm just going to write it reorganized. So I've got x squared take 9x plus y squared equal plus 53 on 4. So we've got x take 9 on 2 squared take 9 on 2 squared plus y squared plus 53 on 4 equals 0. 81, hang on then. Okay, 53 on 4 is, I'm just going to have to do this as decimals. 13.25. 81 divided by 4 is negative 20.25. So we're going to have x take 9 on 2 squared plus y squared equals 7, which means the center is at positive 9 on 2, 0. The radius, root 7. We're getting there. Okay, now we've got an exponential graph. I have no idea how long this has been going on. Because I'm using Zoom to record this video. I don't know when it's going to end. You know how it has that 45-minute limit? Or it did. Okay. Negative 2 to the x plus 1. So here it's upside down. Here it's been moved left 1. But first thing we should do, intercepts. Y-intercept, make x equals 0, y equals negative 2 to the 0 plus 1. So y is just negative 2. X-intercept, y equals 0. We may not get an answer for this. So we've got 0 equals negative 2 to the x plus 1. So negative 0 to the x plus 1. Yeah, that's no answer. So it's going to have no x-intercepts. Let's give us another point. So when x equals 1, we're going to have negative 2 to the 1 plus 1. So we've got negative 2 squared. So we've got negative 4. So now we've got enough information to draw a relatively good graph. Relatively. You've seen some of the ones I've done today. Y, x. So I know it's going to go through the point negative 2. When x is 1, it's going to be negative 4. So it's going to kind of come down like that. Cool. This negative it wasn't -2 to the x plus 1. It was just a negative out the front. So yeah. Here it's been moved left 1. Here it's been moved up 3. Y-intercept, make x equals 0. So y is -2 on 1 plus 3. So y is going to be 1. X-intercept, make y equals 0. So we've got 0 equals -2 on x plus 1 plus 3. So -3 equals -2 on x plus 1. So we've got x plus 1 equals -2 on -3. So x equals 2/3 take 1, so -1/3. Okay, let's sketch it. So x is -1/3. That's the x-intercept. My y-intercept is at +1. Let's put in our asymptote. Our asymptote is obviously x cannot equal -1. And our horizontal asymptote, y cannot equal 3 because -2 over x plus 1 is never going to come out as 0. Here's me automatically, and I always do this, and I always regret it when I do it. Okay. Pretend I'd hit either of those. And this one must go that way. So that's why I used Desmos to sketch. Okay, we're not going to do example 22 because we just did a whole bunch like that. We're going to do example 23. So if we've got y equals root x, that's a lovely one. That looks like this. If I have y equals negative root x, it's upside down. And remember, if the negative is with the x, then it reflects this way. And if you were interested, root negative x is just that way. Okay, odd, even, or neither. We're very close to the end. So remember, if it's odd, then if you chuck in negative x, it comes out the negative of if you just had x. If it's even, if you chuck in negative x, it all comes out in the wash and it's just the same, and either is something else happens. So if I've got f of x is x to the 4 take 3, if I chuck in negative x, then I've got negative x to the 4 take 3, but negative x to the 4 is just the same as x to the 4 because it's to an even power. So I've got x to the 4 take 3, so it's even because that's the same as what we started off with. Question B, if I've got x cubed, when I chuck in negative x, that's the same as, well, negative x cubed is just negative x cubed, which is negative of the original function, so it's odd. C, we've got f of x is x squared take 2x. F of negative x is negative x squared take 2 times negative x. So we're going to end up with negative x squared is just x squared, but negative 2 times negative x is plus 2x. So it's neither. So it went a bit weird. Okay, this didn't stop recording, but now I will. Peace out, bros. I don't know.